Hi everybody, I hope you all are doing great. So till now we have seen some basic problems on dynamic programming and we have got a hang of dynamic programming, right? So from this video onwards we are going to start some very classical problems of dynamic programming. Starting from this problem, subset sum problem, which is a very classical, a must know problem, or you can say algorithm, in order to crack any company interview which might involve dynamic programming, right? So the thing is that this question was asked like to me from Twitter, right? And in a different form. Definitely they didn't ask the direct question itself from me, but only thing changed was the language of the question. Rest I applied the same algorithm which I'm going to write here to crack that interview, right? So let us see what this problem is saying. Subset sum problem. Let's get right into it. So they are giving us an array of non-negative integers and a value sum. Okay. Determine if there is a subset of the given set with the sum equal to given sum. Determine if there is a subset of the given set with sum equal to the given sum. So basically you can see in this kind of test case, n is 6. This means that 6 elements they are giving us in the array. Then they are giving us 6 numbers which are representing the array elements, and these are randomly arranged array elements. They are not in a sorted form or something like that. They're just randomly arranged array elements, and they are giving us a target to achieve. This is the sum we want to achieve. Definitely, can you see that like any three numbers, like any, not three numbers necessarily, any amount of numbers if you can pick from this particular array, can you make the sum 9? Yes. Can you see? So 3 plus 4 plus 2, you can definitely make 9. Here you can see subset sum 9 is getting made, right? 432 is a subset of this array, right? We know differences between subset, subarray and subsequence, right? Subset is just all in a subset, all the elements are there in a subarray, right? So 432 is a subset of this array. So 4 is also there, 3 is also there, 2 is also there, and all these numbers are summing up to 9. So basically you have to tell me, is there any subset? Yes or no? Is there any subset? You have to return in a Boolean format, true or false. Is there any subset which is summing up to the required sum we are trying to achieve? So let us analyze this problem on board and let's just try to understand what the question is saying. So now this is the thing they are asking us, that this is the array they are giving us and the sum we want to achieve is 9. We have to tell whether we can achieve this sum or not using any number of elements from this array. We can use one element as well. We can use any number of elements we want, and just the only thing is that we have to achieve this sum, right? Okay. Now directly we know a strategy in recursion which is pick and not pick strategy, right? So we will directly try to apply that strategy in terms of recursion, because every person in a subset can be there or cannot be there. These are the only two things. If I'm making any random subset, this 34 can be in this subset or it cannot be in this subset, right? These are the only two options everybody is having. So let's try to derive a recursion kind of thing for this problem, and let's try to see if we can do it through recursion itself. So full focus, I'll write the indexes here: 0, 1, 2, 3, 4, 5. All right. Now I'll try to write the recursive, you can say, kind of tree here. So let's ask from 0, right? If 0 comes in, right now the sum remaining is 9. Sum remaining is 9. 9 is what you have to achieve. First I will write the I on which I'm standing on, and second I'll write the sum which is remaining till now. So 0, on 0th index we are standing and sum remaining is 9. Okay, now this 0th person has two choices. Either this person comes or it does not come, right? If 0 comes, right, we'll definitely look for next index, right? Definitely we'll be looking for next index. But if 0 comes, 0th index element comes, can you say that the sum will be reduced to 9 minus 3 for the rest of the elements? 6. What am I trying to say? I am standing on 0th index and I have to achieve the sum 9 from the rest of the array starting from the 0th index. If 0th index decides that it wants to contribute in the subset, can I simply say that if it wants to contribute, the 0th element wants to contribute, the remaining sum to be achieved from the rest of the elements will be 9, which is the overall target which has been given to us, minus the 0th element which is 3 is equal to 6. So from 1 index onwards, if we are able to achieve this sum 6, then we can definitely say that 0th element will enter the subset that is able to achieve the 6th sum, and zeroth element will add a 3 to it, and overall we'll be able to achieve 9, right? So let's continue this recursion and try to understand it more deeply. I know, right, it is not very clear right now to everybody. Let's try to go ahead. Let's be some like, let's have some patience and let's just iterate on it more. All right. So let's say zeroth element doesn't want to enter the subset. Definitely, if it is not coming, then the next answer will be from 1th index only. And are we able to achieve the sum of 9 from index 1 onwards? 0 has not decided to come. This means that this sum is not altered here, right? It is not changed. The sum remains the same. The target remains the same. Because if 0 is coming, right, the target is sum minus the zeroth element. But if 0 is not entering the subset, I can simply say target will remain 9 only, right, for the rest of the elements, because 0 is not like interested in coming. So rest of the elements, it is now dependent on the rest of the elements whether they can achieve this sum of 9 or not. Let us move forward. This 1th index element is having two options: either it comes or it does not come. Now if the 1th index element comes, right, the next answer will be from 2th element. Definitely the next answer will be from 2th element. But if the 1th element comes, can I say that the remaining sum for all the people which they are supposed to achieve, can I simply say that that sum will be what? It is 6 minus the 1th element, which is 34, is equal to minus 28. Basically, if it is not clear till now, what we are trying to say that, okay, if I come, people after me, can you possibly make the sum which is remaining? Okay, so 1 is coming, 1th index is coming. People after me, are you able to make a sum of minus 28 on your own? But if I'm not coming, people after me, are you able to make the entire sum by yourself? Is this clear? So if we are giving our task to someone else, recursion is just like giving our own task to someone else, right? So if I'm coming, definitely the remaining sum is what I want to achieve from the rest of the people. But if I'm not coming, then the entire sum which I want to achieve, I'll pass on to the remain like of the people after me, and they have to achieve that sum. All right. So minus 28. Can you see that this is a negative sum? And in the question they have told us that they are giving us only positive values. Can we possibly able to like achieve minus 28? No, right? So if the sum becomes negative, can I simply say that I'll be returning what? A false from here, that it is not possible to achieve the negative sum from all the positive people which are remaining. They are giving us in the problem itself that only positive integers are there. So definitely I'll not be able to achieve a negative value. You can definitely now note down that this is one of the base cases when the sum becomes negative, right? Let us move forward. So 2 comma 6. Now this 2 comma 6, 2 wants to, let's say second index wants to enter, like make a subset, or it doesn't want to enter the subset, right? So if second element decides that it wants to contribute in this particular subset, can I simply say that it is asking now the people after me, like 2 ke baad it is 3, after 2 it's 3. So now it is asking for all the people after 2. Yeah, are you able to make the sum of the remaining sum, which is 6 minus the 2th index, right? 2th index value, which is simply what? 2 only, right? So people after me, are you able to make a sum of 2? Can you simply say that 2 is of course presented, they will be able to make a sum. Let us move forward and let's try to understand it more clearly. 2 comma 6 is there, all right. It doesn't want to come. Definitely next answer will be from 3. And now this second index is saying, yeah, can you make the entire sum by yourself? It is passing on the entire sum and it is trying to ask that, are you able to make the entire sum by yourself? All right. Now, okay, this 3 comma 2 we are standing on. Now we are asking from 3 comma 2. Yeah, 3 comma 2. If the third element comes or if it does not come, let me draw it a little bit neater. If it comes, if it does not come. Now if the third element comes, you can definitely see the remaining answer will be from fourth element, no matter what, if we come or we do not come. But one thing is for sure, that if this third element comes, the remaining sum will be the overall sum which I want to achieve minus 12, right? It will be a negative value. If it will be a negative value, it will simply be negative 10. Yeah, can the people after this third index, which are all positive people by the way, can they possibly achieve a negative value? No, they can never achieve a positive. Like all of them are positive. All the people after me are definitely positive. That's given in the question itself. they can never achieve a negative value. So if the sum becomes negative somehow, what do? I simply return a false from it. Correct. Now 3 comma 2, if it does not want it, if we are not trying to include the third element, let me bring this here as well. If we are not interested in including the third element as well, if we are not interested in including the third element, so next answer will be from fourth element and the sum will will be as it is. All right, let us try to get more ahead. So this 4 comma 2 is having two options, either it comes or it does not come. If the fourth element comes, if the fourth index enters, right, so fourth index wants to join the subset, the next answer will be from the fifth index itself, definitely. And one thing is for sure, that if fourth element enters, remaining sum will be the overall sum I want to achieve minus the fourth element, which is 2 minus 5, which is what? Negative 3. This is of course a negative value. Negative value we always return false, because of course for all the positive people after me, they can never achieve negative value, right? It is not possible. The target is not non-achievable. Now 4 comma 2. 4 comma 2, what are we trying to target here? If we are looking at this 4 comma 2, can I simply say here, if 4 comma 2 does not wants to join the squad, if it does not want to join, I'll pass on the entire sum that people after me, fourth index is saying people after me, are you possibly able to achieve the sum of 2? Let us see, let us see, let us see. So 5 comma 2, now the questions are on 5 comma 2. Let us see, now the questions are on 5 comma 2. Look at this fifth index we are standing on. If this fifth index comes, if this fifth index comes, or if it does not come, if the fifth index comes, can I simply say that I'll be on the sixth index? It is not actually there, but can I say that I'll be on the sixth index and the remaining sum will be 0? Remaining sum is 0, my friends. If the remaining sum is 0, can I simply say that whatever target is there, I can definitely achieve 0, right? Can I take an empty subset and I'll be able to achieve 0? Exactly. So whenever the sum becomes 0, this means that I've achieved whatever I wanted to achieve. Now the sum I'm targeting is 0. 0 simply means I do not take anybody else after this, right? And I have achieved the sum. So from this particular index, can I say I'll simply return true? Because I've achieved, the sum has become 0. So I'll say that sum is, now I'll be able to make 0 sum definitely if I do not come, right? So I'll simply return true. Okay. If 5 comma 2 does not come, we'll ask from sixth index, but the sum will actually be remain 2 only, right? Sum is getting passed as it is. Now here you can see sixth index is non-existent, and sixth index simply means that there are no more elements left. Here, can zero number of elements make a sum of 2? Never. So if somehow we end up exceeding the array bounds and the sum is still not equal to 0, I'll return false. Again I'll repeat, if somehow we have exceeded the array limits, definitely we have, and the sum is not 0, right? We are still trying to make a sum. This means that it's not possible. No elements are there and I'm trying to still achieve a sum, so I'll simply return false from here. Now 5 comma 2, look at this. This is a very interesting test case. 5 comma 2, if it comes, it is able to make the sum of 2. If it does not come, it will not be able to make a sum of 2. Can I say it will be returning or of these two operations? Definitely, no matter what, if it able to achieve the sum by any means, if it comes or if it not comes, can I say it will simply return true from here? So we are returning this or this, correct? So by any means, if I'm able to make a sum by coming, or if I make the sum, if I'm able to make the sum by not coming, I'll be returning true itself, no matter what. 4 comma 2, if 4 comma 2 comes, you can see we'll not be able to make any sum. If 4 comma 2 does not come, you can see that we can possibly make a sum. So I'll return true from here as well. Okay, look at this now. 3 comma 2, 3 comma 2, if it comes, it is not able to make a sum. If it does not come, it is able to make a sum. So definitely I'll take OR operation of these two values, and definitely I'll say that I'll be able to make, somehow I'll be able to make the sum of 2. For all the elements after the third index, we'll be able to make a sum of 2. You can definitely remember that I told that. Let's see what will happen here, right? So 2 comma 6, 2 comma 6 is deciding, like, if it does not, if it comes, so it is able to make a sum. If it does not come, let's see what happens. Actually, it's not necessary to now to calculate this, but let's do it for these educational purposes only. So if it comes, if it does not come, if the third index come, if it does not come. Now can you simply see that the third index is what? Third index is 12. If it comes, what will it make? It will be asking for fourth index for minus 12 sum. Minus 12 sum is definitely negative, so I'll return false, right? And okay, let's move forward. So I'll if I do not come, I'll be asking for the fourth index with a sum of 6 only. Can you see that these elements will not be able to make a sum of 6, right? Can you see this, right? Definitely, I'll increase the pace a little bit now. 4 comma 6 will ask if it enters or if it does not enter, if it enters or if it does not enter. If it does not, if it enters, can I simply say that the remaining sum which I want to make is from the fifth index, can I make a sum of 6 minus the fourth index, which is 1? If I do not come, I'll ask from the fifth index, but the sum will remain 6. Okay. Can the fifth index make the sum of 1? You can see if it comes, if it does not come. If the fifth index element comes, here I'll be able to make a negative sum and it is a false. And if I do not come, I'll be out of bounds and the value will be positive. So from both these cases, I'll be returning a false. Okay. Now from this kind of case, definitely 5 trying to from the fifth index trying to make a sum of 6. Yeah, it is not possible, right? So I'll do it once more. Comes or do not come. Fifth index decides to enter, fifth index do not want to enter. Now if fifth index do not want to enter, right? If wants to enter, let's see what will happen. It will ask for sixth index and the remaining sum will be 6 minus 2, which is 4. You can see 5 comma 6 is there and 5 comma 6 is trying to decide what? It is trying to decide, are we able to make a sum of 6 after the sixth index? Now definitely this is out of bounds, still positive, and out of bounds, still positive. So we will return false from these cases as well. And you can simply see that now from these two cases, no matter what, I'll not be able to, of course, yeah, fifth index will not be able to make a sum of 6, right? All the people after sixth index, only one person is there, it will not be able to make a sum of 6. I'll return false. This also returns a false. This also OR operation, I'll return a false. 3 comma 6 is saying no matter what, I'll not be able to make a sum of 6, right? So I'll return a false. This 2 comma 6 says that if I come, I'll be able to make. If I do not come, I'll not be able to make. So I'll return true because somehow I am able to make a sum, right? Now, okay, 1 comma 6 we have returned. From 1 comma 6, of course, 1 comma 6 will also return a true, that I'll be able to make a sum if, I come, right? From the 1th index onwards, can you simply say from this 1th index onwards, I'll try to make a sum if it is possible or not, right? So definitely I'll simply say that if I come or if I do not come, right? Now this is the whole recursion, you can say, approach of this problem, right? In this particular test case, I don't think we were able to see the overlapping sub problems, right? I think if we expand a little bit more, we'll be able to see the overlapping sub problems. And one thing is for sure, if the elements will be repeating, can I simply say that there will be overlapping sub problems? I'll be asking the same thing again and again, right? So note, right now no to recursion calls are same, I think. Yes, I think yes. Right now no to recursion calls are same, but definitely there will be some overlapping sub problems which we'll be trying to calculate answer every time, right? So, and what would be the time complexity of this recursion? Here it would be 2 raised to the power n, right? 2 is power n. Every element is having two choices, either it wants to come or if it does not want to come. If you want to understand how it has two choices, so you can say that, this is permutation combination. If the zeroth element comes, it is two options. It is in two ways. We can say that zeroth element comes or it does not come. In two ways, the one-th element is also having two ways to come or not come. Two possibilities for this as well, two possibilities for this as well, two possibilities for this as well, and everybody gets multiplied. This makes the time complexity 2 is power n, right? So this is a very bad time complexity, and definitely it is just due to the overlapping subproblems. Although it is not visible in this particular case, but definitely there will be some overlapping subproblems. And what we'll do, you can see two parameters are getting changed. So I can simply say that I'll be taking two-dimensional DP and I'll try to solve this kind of problem, right? So let us try to write some recursion pseudocode for this. I hope that you will be able to complete this tree by yourself, right? And do try to complete this tree by yourself because it is very important to practice recursion tree as well. Dynamic programming is a good thing, but if you have not practiced the recursion trees, you will not be able to think for the approaches for the upcoming problems. So do complete this by yourself, definitely. I'll be moving to the recursion pseudocode and let us see how we are going to code recursion itself. So let's try to write the recursive function for this pseudocode kind of thing. So I'll write a function recur, right? And here I'll pass parameters. What I'll pass the array, I'll pass the index I am standing on, and I'll pass the sum. Right? Exactly what we are doing. I and sum, these are the two parameters I need, and of course the array to refer that array and what index we're standing on. So now you can see, before writing the base cases, I simply write the body of this recursive function. So we are standing on the ith element. This ith element is having two options: either it wants to come, or if it does not want to come, integer come is equal to what? Recur for array will be as it is. Next answer will be from I plus 1th index, and sum will be what? Sum minus ARR of I. This person is trying to come. So can I simply say that this has been reduced to what? The sum has been reduced, right? I am coming. Of course, it will be Boolean, right? Boolean. All right. Now, if I want to come, like this will be giving me the answer if possible or not. If I do not want to come, don't. What will I say? I'll recur for array I plus 1. But sum I'll pass as it is because I'm not coming, and I'll simply say that if I'm not coming, I'll not enter, you can say, the thing itself. Okay, so comes and does not come. Okay, okay. Now what do I have to do? Okay, these things I have completed. Come and I do not want to come. Now my option is, if I want to come or if I don't want to come, is there possible, if it all possible, if it is all possible that I can achieve the sum or not? I'll simply return of come or don't. Correct. Return come or don't. Right. If I come or if I not come, anywhere, if it is possible to come, if it is possible to make the target achieved, if it's possible to achieve the target, if ith element enters the subset, if it is possible to achieve the target, if ith element doesn't enter the subset, any possible thing, I'll return or operator. Right. Let's look at the base cases now quickly. One base case is definitely when the sum, as soon as the sum becomes 0, I'll simply return true. So if sum becomes 0, I'll return true. Okay. If. Now, the second thing is what? If the sum becomes negative, can I simply say if the sum becomes negative, less than 0, I'll return what? I'll return false. Because from the positive numbers, negative sum is not achievable, so I'll return false. And if the sum is not 0, then only we'll be standing on this if statement. If the sum is not 0 and I is equal to what? Arr dot length. We have exceeded the array limits and the sum is still positive, so return false from here as well, right? So this is the pseudocode for this. Let's quickly write the recursive code and then we'll convert it to memoization. So we are on the code editor as itself. So I'll simply, let's quickly write the function here. Static boolean recur. Okay. And now what I'll do, I'll pass integer a, I'll pass I, and I'll pass the what? I'll pass the sum which I want to achieve, right? So let's quickly write the body of the function first. So boolean, if I come, right, recur for arr comma I plus 1 and sum minus arr of I, because ith element is coming. We are picking the ith element. Pick, not pick strategy. We are picking the ith element. This means that sum minus arr of I is the remaining sum. Boolean, if we do not pick this, don't is equal to recur arr I plus 1, but the sum will be as it is because I want to achieve the same kind of sum from the rest of the people. I'll return come, or if I come or if I don't. Right. So this is the recursive body itself. These are two options everybody is having. If it enters, if it does not enter. Now the base case is if the sum becomes 0, somehow the sum becomes 0, I'll return true. That yes, I have achieved the sum. If the sum becomes less than 0, I'll return false because negative sum is not possible at all. If I is equal to arr dot length, this means that I'll return false from here as well, that I am not able to achieve it, right? So this is the recursive function itself. Let us quickly call this recursive code and let's see if it is working or not. Then we will convert it to memoization itself and then we'll see tabulation. Actually in this problem now, tabulation is kind of very interesting, right? We'll see it. So tabulation is a, like, don't have to miss tabulation, this kind of problem. We'll definitely we can use the trick as well to convert into tabulation, but we'll not, right? We'll do something else, right? So recursion is complete. The function is running just fine. We are able to achieve the sum, and actually it is the same recursive diagram which we drew only, and it's working fine. Let's convert it to memoization quickly. For memoization, definitely you can see there are two parameters which are changing. Sum is changing and I is also changing. This means that I have to make a dp of what? Two dimension is equal to new integer dp, right? And the length will be what? I'll take it n plus 1 and sum plus 1, right? I'll take it a little bit extra, right? So n plus 1 I'm doing just for safekeeping, right? I don't need the n plus 1 nth index, but for sum plus 1 I'm doing because I'll be asking for dp of 0 comma sum. So that's why I need the sum plus 1th index to accommodate that sum, you can say, column itself, right? So dp of sum I want to achieve. Okay, sum plus 1 and n plus 1 I'm giving here. All right. Static. I'll actually copy this whole function as it is, and I'll just edit this function. This is what we do in Memoization, right? I'll just write it memo. I'll write here also wherever I'm calling recur function, I'll write memo, and here also I'll write memo. Okay. So Memoization I've called. Wherever I'm doing calls, I have to pass dp as well. I'll pass the dp array as well, right? And of course, this dp array would be of integer. It would be of integer, right? Initially everything would be filled with zeros in this array. This denotes that 0 means that I have not found the answer. If dp of I comma j is 1, this means that I've calculated the answer and the answer is true. If dp of I comma j is equal to minus 1, I'll say that I've calculated the answer and the answer is false, right? dp of 0 means not calculated, 1 means true, minus 1 means false. So now recall, if dp of I comma j is somehow not equal to 0, this means that we have already calculated the answer and simply return what? dp of I comma j is equal to 1 or not. If this boolean expression comes out to be true, I'll return true. If this boolean expression comes out to be false, I'll return false, right? I'll simply return dp of I comma j is equal to 1. And now these operators, now you have to understand very beautifully, because this expression, this is definitely a boolean expression. If it evaluates to true, this means that the answer for this is true, and that's what I want to return, right? dp of I comma j is 1 is equal to 1. This means I want to return true. So I'll simply write this boolean exception instead of writing an if else statement, right? You have to use these kind of things. They help actually in the interview itself. They can portray that you know what you're doing in a programming language, right? The only thing which is remaining is I'll have to remember the answer for as well. So for remembering the answer, dp of I comma j is equal to come or don't. Any one of them is true. I'll keep a 1 here or I'll keep a minus 1 here, and I'll return come or don't here itself. And this is what the memoization code is looking like. Of course, here also I'll write dp. I'll have to accept dp array here, and yes, this is complete. Let us now pass this dp array here and let's call memo function, and let us try to submit this problem itself. Again, I'm repeating, I do not submit the codes of recursion because I definitely know they'll be exceeding, right? And of course I have taken j here, but actually j is what? The sum itself. dp of I comma sum is I want to achieve, right? So wherever I have written j, I have to replace it with sum, right? Sum. Yes, dp I'm passing as it is. Here also I'll write a sum here. I'll write a sum, and I hope that I have not written j anywhere else. Let's try to submit it, because I and the sum are the two parameters which are changing. So I'll keep a dp of I comma sum, right? It is passing. Let's try to submit it and see if it works, and then we'll move to tabulation of this, right? Okay, so it's working successfully. Now the thing is, you can definitely use the trick I've taught you to convert this memoization to tabulation, but I'll not do that because there is no learning in that. I'll try to build this tabulation for this kind of problem from scratch, and you'll see how interesting tabulation can be, right? How logically you can fill tabulations as well, right? So you can definitely try converting this memo code to the tabulation code itself by using the trick. But keep in mind, these base cases you have to keep in mind very closely, right? It would work and it will be converted easily into the tabulation code using the trick itself. Let's quickly see the tabulation code through logic itself. Let's try to understand the tabulation itself. Now I've set up this tabulation kind of table. Don't worry, it might look overwhelming right now. Let me explain everything. So this is the test case I'm looking at. These are the elements I'm having, and this is the sum I want to achieve. Okay, I've made the dp of n plus 1 comma sum plus 1, right? Exactly what we are doing. in the like memoization code as well. So n plus 1, sixth index we are having here, and m plus 1. I would say sum plus 1 because I want the summat index, right? Full focus के साथ दिखना है. This particular area, this number of these columns, these are the array indexes, right? But of course, the zeroth element is on oneth index. This element oneth index is on second index. The second element is on third index, and so on. I've shifted them a little bit, right? Just one step ahead, right? And these are what? These are the sums. This represents the sum. This represents a sum. This represents a sum of 5. This represents a sum of 6, right? Now, what will I store in a particular position? What will I store in a random, you can say, cell of this DP? This will tell me, is it possible to make a sum of 3 using all these elements? Okay. Now, what will this represent? This. Is it possible to make a sum of 6 using all these elements? Of course, using all these elements, is it possible to make a 6, right? So, this is how the DP is looking, right? Let us try to fill it out. First, logically. Look at this. Can I make a sum of 0? Can I make a sum of 0 using a 0? Using 0 elements, using no elements. Definitely, it is possible to make a sum of 0 using no elements. This is another way to think for deep tabulation solutions, right? And it is a very important angle of approach, right? So, it is possible to make a sum of 0. These are all the sums. These are all the sums. It is possible to make a sum of 0 with using 0 elements, right? Okay. It is possible to make a sum of 0 using 0. I have written true here. Is it possible to make a sum of 1 using 0 elements? No. False. Is it possible to make a sum of 2 using 0 elements? No. False. 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 And false and false. Everywhere there'll be a false, because any positive value is not able to achieve if you are using no elements, right? Let us look at this now. Is it possible to make a sum of 0 using these elements? Can I simply say that I'll use no element, and yes, it is possible. 0 sum is possible because I'll take empty subset. Definitely, empty subset is a subset. Okay. Is it possible to make a sum of 1 using all these elements? It's not possible. Right now I'm feeling only logically, right? We'll generalize the approach a little bit further, but don't think about the code right now. Do not think how we are going to implement it. Just try to fill it logically with me. So you can see that it's not possible to fill here. So false. Is it possible to fill this place? Is it possible to make a sum of 2 using all these elements? Yeah, only 3 is there, and I'll not be able to make exact sum of 2, right? So false. Is it possible to make a sum of 3 using all these elements? Yes, I'll use this third element, this element 3, and I'll write true here. Okay. Is it possible to make a sum of false, right, 4 using all these elements? No, it's not possible. I need some more elements. It's not possible. 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 Okay. All right. Let us try to move forward. Now look at this 34. Yeah, is it able to make are we able to make 0 from all these elements? I'll take no elements, and yes, I'll be able to make 0. In a way, can I say no matter what, I'll be able to make a 0? No matter what, I'll be able to make a 0 itself. Yes, definitely I can. Okay. Now full focus. Look at this. Yeah, is it possible to make a sum of 1 using what? Using what? 34. All these elements? No. I'll write false here. Right now I'm feeling only logically. Is it able to fill? Are we able to fill this particular person sum of 2 using all these elements? No. It's not possible. So false here. Are we able to make a sum of 3 using all these elements? Definitely. If 34 does not come, can I simply say I'll ask if 34 is not like wanting to come. 34 will ask the people previous to itself, here, are you all able to make the same amount of sum? It is asking 3. Are you able to make the same amount of sum? 3 is saying yes, I can. So I'll write it true here. This means that using all these people, I'll be able to make a sum of 3, and it's possible. Don't worry if it's not clear. Don't worry. We have a long way to go. It will be cleared. Don't worry. Okay. Are you able to make a sum of 4 using all these elements? Definitely not. Are you able to make a sum of 5? Definitely not. 6? No. 7? No. 8? No. 9? No. Correct. Is it possible to make a sum of 1 using all these elements? Definitely no. Okay. From this particular index onwards, we'll start to generalize the approach. For these two rows, I'll generalize the approach. Full focus. देखो यार. So 4, we are not able to make sum of 4 here. Look at this particular instance. Are we able to make a sum of 2? Definitely not. I'll write a false here. I'll be able to make a sum of 3. Definitely. Using all these, any of these, a subset from these elements can be used to make a sum of 3. Can we make a sum of 4? You can see definitely we can make a sum of 4. Now this is a very important place. This is a very important place. Look at this. Let's try to generalize right now only. Full focus का देखना है. 4 is having two options. If fourth element comes or if it does not come, now related to recursion. 4 is having two options, if it is coming or if it is not coming. If fourth element is entering, can I simply say that I'll be asking that from the remaining elements, from these elements, I'll ask what? Are you able to make a sum of 3 minus 4? 3 minus 4, because 3 is what the target I want to achieve. This is a very peculiar place here. 3 is the target I want to achieve. Correct. 4 is coming. This means that remaining sum is what? 3 minus 4. This is minus 1. Can these people make a negative sum? Definitely not. Definitely not. This means that 4 will not be coming. ये option तो गया that 4 is coming. This option is gone. Now let's try 4 does not come. यार if 4 does not come, these are the remaining people. These are the remaining people. And what is the remaining sum? 4 is not coming. This means that 3 will be the remaining sum itself. So I'll ask that are you able to make the sum of 3 using all these people? This is exactly what we are doing. Full focus. I'll write it true here. Let us look at this very important example. 4 is having two choices. Either it comes or it does not come. If 4 decides to enter the subset, can I say 4 wants to enter, the remaining sum will be 0. 4 minus 4. 4 is coming. Am I able to make this particular sum using 0 sum using all these elements? Where is the answer? Can I say here is the answer? Yes, I am able to make 0 sum using all these elements. So when 4 comes, the answer is true. When 4 does not come, let's see what is the answer. When 4 does not come, क्या हुआ यार? Sum will remain 4 only because 4 is not coming. But I'll ask from the previous people. Previous people, are you able to make a sum of 4? They are saying no, we are not able to make a sum of 4. So these are the two options. We'll definitely keep an OR operator and true will stay here. Is this clear? Now let's try to generalize a little bit more. So this is not possible. I'll write a false here. This is not possible. I'll write a false here. I'll write a false here again. No, false here again, false again. Let's write out for 12. Not 12, all these people. For look at all these. We are not just looking for 12. We are just looking for all these people. Now look at this. Are you able to make a sum of 1 using all these people? Definitely not. Are you able to make a sum of 2 using all these people? Definitely not. Even if 12 comes or if 12 does not come, we are not able to make this sum. Look at this. 12 will ask 3. Are we able to make all these people? The sum is equal to 3 using all these people. Let's see. If 12 wants to come, can I say from the remaining people, I'll be asking what? From the remaining people, I'll be asking what? I'll be asking what? I'll be asking, are you all able to make a sum of 3 minus 12? Yeah, this is a negative sum. This means that it is not possible, right? Negative sum, can you see on this number of rows? There's no option for negative sum. So it's not possible. It's out of bounds. I'll try to access the index, the row previous to me. The row previous to me saves the answers for all the people before me. All these answers. And the column is 3 minus 12. And that will definitely be a negative column. So I'll write a false when 12 wants to come. I'll write a false. Let's say if 12 does not want to come. So all the people before me, all these people, are you able to make a sum of 3? Yes, they are able to make a sum of 3. So just the row above me, the same column, because the sum is same. If I'm not coming, the sum will remain the same. I'll write true here that yes, we are able to come. Now true or false, what would we do here? Definitely I'll write a true here that we are able to achieve. Look at this 12, of course, we'll be having two options, either to access I minus 1 ask from I minus 1 people. Are you able to make a sum of 4 minus 12? Or what? I minus 1 people, are you able to make a sum of 4 if I do not come? This is the case when I want to come. This is the case when I do not want to come. Look at this. This is definitely a negative j column. This means that it will result to be false. This will result in what? This will definitely result in this particular previous index, previous row only. So here true is written. I'll write true here. Definitely all these places will be filled with false itself because all of them will be Either negative columns or all of them will be, not be possible for the previous people to achieve, right? Okay. 12 is because is a very big number. Let's look at this 5. From this row now you will get the complete understanding, I promise. The answer there. So now, can we make a sum of 1? 5 will ask, can we make a sum of 1? If 5 comes, can I say, I'll generalize for everybody now. If 5 comes, what will I say? Here, I minus 1 people, are you able to make a sum of 1 minus 5? Negative sum. They'll not be able to make negative sum. I minus 1 people, if I do not come, are you able to make a sum of 5 itself? Are you able to make a sum of 5 itself? You can see n I minus 1 people are not able to make a sum of 5. This means I'll simply write false here. Same for this. I'll ask for 2 minus 5 and I'll ask for this index only, this you can see this row only. So I'll simply say that I'll simply write, so it is I'll for 2 it was 2 here, and now like it was 1 earlier, now it is 2 here, so I'll write a false here. Now the sum is what? The sum is 3. If 5 decides to come, I minus 1 people, are you able to make a sum of 3 minus 5? This is the original sum I want to make. 5 is coming, minus 5 for that. Negative column they'll not be able to make. I minus 1 people are, if I do not come, if 5 does not come, are you able to make the remaining sum? Remaining sum is the 3 totally. So you can see I minus 1, 3. Definitely they are able to make. I'll write true here. Are you able to relate to the logic? Right. If I do not come, if I come, these are the only two choices I'm having all the time. So I minus 1 people, are you able to make a sum of 4? Now, full focus. For these two things we'll see again. And then I'll generalize. So I minus 1 people, so 5, if 5 decides to come, I minus 1 people, are you able to make a sum of 4 minus 5 wants to come? This is a negative column, they'll not be able to make. Or I minus 1 people, if I do not come, are you able to make the sum 4 entirely by yourself? Let us see. Yes, they'll definitely be able to make a sum 4. You can see I minus 1, 4 is definitely true. I'll write a true here. This 5 case is very interesting, and then I'll quickly wind this up. So I minus 1, look at this. In this index I am to fill that, are all these people able to make this much sum? Let's see. A subset from all these people able to make this much sum. Let's see. I minus 1 people, are you able to make a sum of what? 5 minus 5, because now the first call is 5 is trying to come. 5 minus 5. Are you able to come? Or what? I minus 1 people, are you able to make a sum of? Are you able to make a sum of what? Are you able to make a sum of what? Are you able to make a sum of 5 entirely by yourself? They cannot make a sum of entirely by themselves. But one thing is for sure. I minus 1, 5 minus 5 is 0. You can see here. Look at this. It will ask this column and it will ask this column. The OR of these two things. It is true. I want to fill this. If 5 does not come, it will ask this column. If 5 comes, the remaining sum will be 1. It will ask this column. OR of these two people will be what? It will be simply, yes, it will be true. Look at this. I minus 1 people, if I come, if I do not come, am I able to make a sum? Right. You can see, yes, false is there, so definitely I'll not be able to make this much sum. Look at this 7. But one thing is, I think I missed one thing. So using this much, we can make a sum of 7, right? So this column, look at this column. Definitely when 4 was there, when 4 tried to come and when 4 did not try to come, so 7 minus 4 is 3 only. So I'll be able to make a true here. So I'll have to write a true here. All these people will be true, right? It's a little bit mistake from my side. So okay. So okay. I think I'll not be able to make any other kind of sum, right? So look at this. All these people, are you able to make a sum? If 5 does not come, if 5 comes, 7 minus is what? This. So all of these two people, it will be able to make a sum of this. Are you able to make a sum of 8? Let us see. If 5 comes, false. It does not come, false. If 5 comes, what will the case? Let's see. So all these people, are you able to make a sum of 8? If 5 does not come, I'll write false here. If 5 comes, right? So I minus 1 people, are you able to make a sum of 3? 8 minus 5 is 3. Yes, they are able to make a sum of 3. This means that all these people will be able to make, all of these two values will be true. This means that they'll be able to make a sum of 9. If 5 does not come, are we able to make a sum? Okay, let us see. All right, will not be able to make a sum. But rest of the people, can you possibly make a sum of 9, right? If 5 comes, right? If 5 comes, what will be the case? If 5 comes, क्या करेंगे? 5 minus 4 is 9 minus 5 is 4 only. So yes, there's a true here. This is the case, right? Now for the last row as well, we are going to do pretty similar thing. So 2, if it does not want to come, definitely the people before me, are you able to make the sum of 1? They are not. And if I enter, will I be able to make a sum of 1 here? I'll try to ask from -1%, so it will definitely be false. Will I be able to make 2 using all these people? Definitely you can see if we use this only, then I'll be able to make 2. If I do not come, the previous people will have to make a sum of 2, which is this cell itself, this and this. And if I do come, right, the previous people have to make the sum, which is target minus 2 is coming. So 2 minus 2, which is 0. So this cell, all of these two cells will definitely be true only. So I'll write true here. Now here you can definitely see whatever is above us definitely comes us here. This also comes here, this also comes here, and so on. And in the last row you can see, look at this particular cell. Can I make this sum 9 using all these people? This answer is here, true or false, right? And this is how you have to think in tabulation when you are looking at this problem. The options are same, coming or not coming, but the only thing which is different is a way of looking at tabulation, a way of logically filling the tabulation, right? Because in some cases you can directly go to tabulation as well, and it is important to remember that what tabulation actually means. It is also getting filled meaningfully, right? Till now I have been telling you a trick to fill tabulation. It might seem very weird, right, that we simply write a trick and it works, right? But tabulation also actually fills logically, and this is how we do it. Let us quickly see the code of this tabulation. We'll directly only code the tabulation itself. You can of course try the trick out, but we'll code for this tabulation itself. So we are back in the code itself. Let me write a function here for the tabulation itself. So static boolean tabulation, right? Integer array, ARR, integer sum, right? These are the two things I want to get, right? Now what I'm supposed to do here is simply I'll create a DP, right? Just like this only. I'll simply like copy paste this line here. So I'll create a DP of sum n plus 1 and n minus 1, right? Okay, so I've created a DP here, right? Now what I want to fill, I'll be start first. Can I simply fill the 0th column, right? Can I fill the 0th column itself? You can see in this 0th column everybody is true. I can definitely fill it beforehand, right? I can definitely fill it beforehand. So I'll do what? I'll simply I is equal to 0, I less than equal to n, because I am taking one extra row, I plus plus. For integer j is equal to 0, j less than equal to sum j plus plus. I'll simply do what? I don't need this loop right now. So I'll simply do what? I'll simply fill first beforehand I'll fill whatever I know. So I'll fill that for every valid answer, right? If the definitely DP of ith row but 0 sum will definitely be equal to true, because we already know, right? I'll make it of boolean, right? Boolean here and here as well, right? So this is a boolean DP, and first column, the 0th column will definitely be true for everybody, because like we want to make 0 sum. So how can we make 0 sum? It is possible to make 0 sum with this, right? Now what do I have to do now? For integer I'll start traversing from 1 comma 1. Integer I is equal to 1, I less than equal to n, I plus plus. For integer j is equal to 1, j less than equal to sum and j plus plus. What I'm supposed to do here, look now very closely, right? If that ith element do not come, right? So what I'll do, boolean don't is equal to dp of can I minus 1 people create j sum. The same sum is j, right? Can I minus 1 people before me, can they create the column one which the sum amount of column which I'm standing here, right? This will look like this. So let's say we are trying to fill this particular cell. So can the people before me, if one doesn't come, the 1th index element doesn't come, can the people before me possibly fill this equal sum? So this is the cell we are going to access. So I'll simply write boolean don't is equal to dp of I minus 1 comma j. If I want these people to, if I want this ith person to come, right? Actually, I is 1. So the person is on error of I minus 1, right? As you can see, the 0th person is mapped with 1th index. 1th person is mapped with 2th index. So whatever row I am on, that row minus 1 is the person which is present on that particular row. So what I'll simply write here, I want to come. I want to, right, in the particular subset, right? What is going to happen? So integer me is who? Who am I? I am error of I minus 1, right? This 3 will be stored in me for row 1, correct? So if I want to come, I'll try to access boolean coming, right? Coming is equal to dp of, can all the people before me, can they make the sum which is equal to j minus me? Because I am coming, they have to make the remaining sum j minus me. Is this clear to everybody? Sometimes it can be the case that j minus me can go less than 0. It can be negative, right? Look at this case. So 12, if we are trying to make a sum of 3, right, and we are saying that let's say 12 wants to come, so it will definitely be I minus 3 minus 12, I minus 1 and 3 minus 12. 3 minus 12 will definitely be a negative column, and that column doesn't exist. So I'll write a check here. If j minus me is greater than equal to 0, then only consider this dp. I'll write a question mark here. Else I'll do what? Else I'll simply write false here. Correct. Now what do I want to store in my place? dp of I comma j will simply be equal to don't coming or don't. It will simply save this information, and in the end I'll be returning dp of n comma the sum. Right, this is what I'm going to return, and this is the tabulation code itself. Let us quickly run this function itself. Return tabulation, and here I'm going to pass array. I'm going to pass sum here. Let's see if this is working just fine. Let me create n as well. I think variable n is not being created. Is equal to error.length. Okay. Now let's compile and run. Let's try to run this problem itself. It is actually giving me an error on some line. So here I have to write this. So I'll fix this. I think there are no more errors. I try to run it now, and then we'll submit it. This is the tabulation code for the same problem. Now you can definitely use the trick to create tabulation as well, but you will not learn something new in that case, right? That's why I took this approach to explain tabulation in a different format as well, right? In tabulation, we are going to 0 all the way to the n itself, right? We are not going to from base cases to 0. We are going from 0 to n in this particular case of tabulation, right? But if you will convert this memoization to the trick I have told you, you will definitely use the same paradigm, and tabulation will go from the base cases to your initial recursion call itself, right? And yes, so this is the problem, subset sum problem. It is a very important problem, my friends, and I hope you are enjoying these lectures, because these problems we are covering, these are the classical problems, and from this lecture onwards we are going to ramp up things. It is not, I'm not sure if you have understood this tabulation or not. Definitely there will be some people, everybody is having same level of, not everybody is not having the same level of understanding. So don't worry if this is somewhat clear. I just want that kind of explanation, right? You can of course rewatch the video as well, but the thing I want to ensure, right, for in the upcoming videos, I'll be making familiar to you with this approach as well. Of course, it is not very intuitive to just create the array of this much length, right? We'll be using the DP trick as well, but you have to understand this tabulation kind of approach as well to a single problem, right? So I hope you are enjoying the lectures. Thanks a lot everybody for joining. Thanks a lot for the support. Recently we hit 200 subscribers. That is a huge milestone for me, and I hope you all will keep supporting me in the same way that you are doing right now. I hope you are enjoying the lectures. Thanks a lot everybody for joining. Until the next video drops. Bye.